All right, so welcome you all to the third day of the conference. And so we are looking forward to listening to the third plenary presentation, which is going to be given by Professor Manuel Armada. And this will be a presentation given on behalf of Professor Yvonne Boudoir, who unfortunately had some kind of accident, and so he could not actually be here to present the presentation. But Professor Manuel Armada has kindly agreed to do the presentation, because the project which he's going to talk about, he has been involved in that as well as a collaborator. But before he starts, I think I'll say a few things about Manuel. I think a lot of you would know about him already. But just very briefly, Manuel Armada is a member of the IEEE. He's received his PhD degree in physics from the University of Valladolid, Spain in 1979, and the title of honorary doctor from State Technical University, Russia, Moscow in 2007. He was director of the Instituto de Automática Industrial, so they abbreviated as CSIC, from 2009 to 2010, and director of Center for Automation and Robotics at CSIC UPM, Polytechnic University of Madrid, from 2012 to 2015. He is currently a professor of research at CSIC, Spanish Council for Scientific Research. He has been a principal investigator in more than 60 RTD projects, including international ones, such as Eureka, ESPRI, Bright Theorem, Growth, ICT, NMP, and so on and so forth.
Вот видите, вот зашел на конференцию, вот уже сейчас доклад начнется.
And others outside EU, particularly in Latin America, joint projects, in fact, schemes like SciTech, ACED, and Russia, ECEDAC EC project, and joint projects between RAS, CSIC. He has also carried out work in several EC thematic networks, such as CLAWAR', and then as a trustee in CLAWAR Association, representing Spain, in fact, at International Advanced Robotics Program. He has been presented with the EMECO TC17 award and with the SIC Distinguished Award 3 times. His main research interests include robot design and control, with a special emphasis on force control and walking and climbing machines. I would invite Professor Manuel Armada to tell us about the work under the Robotics Assistance to predict, prevent, detect, measure, protect, manage, and improvise CBE risks. Manuel, over to you, please.
Very good morning. Thank you very much, Professor Toki, for these kind words. As you introduce this plenary session, I am going to make a presentation on behalf of Professor Yvonne Boudoir that suffered a small accident, home accident, and he cannot do his presentation. First of all, because we are theoretically in Moscow, I would like to say that Professor Boudoir and myself dedicate this presentation to the memory of Professor Valery Gradetsky, that has been a very good friend of us and has accompanied us very much in many years, both in CLAWAR conferences and also in the International Advanced Robotics Program meetings. So we dedicate this presentation to him. also he has been working on this in the institute that organizes this CLAWAR 2020. Well, I am going to go ahead with the presentation. We are going to review some aspects of robotics assistance, or what is the assistance of robotics that can provide to some aspects of some risky situations based normally on improvised devices. In this case, we are going to speak about improvised chemical, biological, and explosive devices, but in general, robotics can help, we think, very much in some aspects, or in some complementary aspects. One aspect that Professor Baudoin, myself, also Professor Muscato, that is here in the conference, has been working in the last years, is in the protection of first responder. So we are working in some projects or in some proposals regarding the protection of first responders, like medical people, police, or and so on. The context of this work started more than 20 years ago within the CLAWAR network. You know that now we are organizing these conferences within CLAWAR Association, but before CLAWAR Association there was two networks of excellence funded by the European Commission that were called CLAWAR, and in the first run of CLAWAR there was several work packages, and in one work package was work package 9. Professor Ivan Baudoin was leading a big task that ran for all the network, that was humanitarian demining, HUDEM. After HUDEM, after humanitarian demining, and apart from CLAWAR, Professor Baudoin was able, with many people in Europe, to set up a very big integrated project funded by the European Commission regarding a toolbox for doing some assistance in the field of anti-personnel landmines. Okay, the structure of the presentation is to give a general view of the, let me say, the state of the art, from where we come and where we are going to, and how robotics can help in the next years. So we are going to revise first the context, then we are going to explain a little bit what is the threat. The threat is very complex. This is a very complex situation, as we will see. Then we are going to make some comments on how to counter these threats. Then we are going to make some considerations regarding prediction, the steps for prediction, the threats. And then we are going to present the view we have regarding the role of robotics. The context where we are working is the chemical, biological, radiological, nuclear, and explosive. Normally, you could see only chemical, biological, radiological, and nuclear. But we add, or some people add also, the explosive part. Because as we present in the title of this speech, this talk, we are speaking about improvised. Improvised could be many times that explosives are one part for the launching of this threat. Because this is a problem that attracts and is very socially very important. There are a number of conventions, especially after the Second World War, that prevents or that regulates the use of this kind of substances in order to avoid damage to the people. In particular, we have a first convention, which is the Chemical Weapons Convention, that was signed by many countries, excepting what are these countries that are here, and in the case of Israel, that is applied, but that is not ratified. You know that normally in this kind of conventions, it is necessary to sign and then to ratify. This convention is on the prohibition and development of production, stockpiling, and use of chemical weapons, and on their destruction. So when these conventions are made, there are not only the prohibition of manufacturing this kind of substances, but also the means to destroy what has been in the warehouses for that. This convention is in very good situation, in the sense that covers 90%, 98% of global population, and are having many inspections running. In any case, you know that there has been some in some recent wars, there has been some problem with chemical weapons. Another that very important convention is the Biological Weapons Convention, which is the prohibition of the development, production, and stockpiling of bacteriological, biological, and toxic weapons. Toxin is very important, and their destruction. And there are some countries that has not never signed it, so they are not applying for this convention. And you can see here in the map how is the situation. There is a treaty on the non-proliferation of nuclear weapons. They know in different names, but normally it's Non-Proliferation Treaty, or NPT. This you can see in this map what is the state of this treaty, and there are some indications depending on the countries. South Sudan, for example, is the only African nation non-signatory of this treaty. So it's here. Then there has been many other situations. Then you see the situation of China and Pakistan and India on that. This is a very relevant situation. And then we have the Ottawa-Oslo treaties for the prohibition of anti-personnel landmines and cluster munition. Cluster munition. This is very important. There are many countries applied, but there are countries not applied. And there is a very relevant information always on anti-personnel landmines. Is something that for the society is very important, and there is a lot of information and of public awareness of this situation. Now we can start to make some comments regarding what is the real threat. So we are going to explain our idea of how robotics can help to solve some problems with these threats, but then or before, we need to know how are the threats. Normally, we are going in this presentation to be regarding chemical, biological, and explosive threats, but it could be for all the possibilities of CV, R, and E. One way of doing the one explanation is that to consider this full possibility and to use how to use the chemical, biological, nuclear devices for preparing improvised explosive devices. Down this slide, there are some explanations regarding the acronyms, because the acronyms in this area are a lot of them. But okay, these systems means weapons of mass destruction or weapons of mass disruption. Depends on that. But it's normally is weapons of mass disruption. There are, with the chemicals, for example, there are two possibilities. There can be some deliberate use, or can be accidents. In the case of biological, it can be deliberate, that is a bioterrorism, but can be natural, like what we have now with the pandemic now, with the COVID-19, which are a natural situation. And they happens with the same cases. It's possible with these elements to build up improvised devices. But what is an improvised device? Or if you like to say, an improvised explosive device. An improvised explosive device was very common in, let me see, is known from long time ago, years and hundreds of years, but especially in the Iraq war in the 2003, started to be used very much. And what means? Means that it's a kind of homemade bomb for destroying or incapacitate or distract the enemy or the regular forces. The IEDs are used by criminals, vandals, terrorists, and insurgents, come in many forms, ranging from a small pipe bomb to a sophisticated device, and can be carried or delivered by vehicle, by person, and so on. You see here some systems. So these are improvised because it's not made in manufacturing. What is the aim? The aim in what respects to our research is more against normal people and against civilians. And against civilians, there is one important part, that is what something happens, some incident happens, the first responders are arriving to one place, for example, the police, the fire brigades, medical assistants, and so on. And then there is an attack using an IED to that. For example, and also in the last times, there are many new possibilities to get these systems more and more destructive. By other side, we can have chemical weapons, and we can have, to distinguish better the two differences, we have chemical weapon is a manufactured standard ammunition, and therefore the way of delivering is conceived and engineering to this purpose. But a chemical IED takes the advantage of the IED, the improvising system, to delivering agent, and the efficacy is not assured, but in any case is very destructive. So the first is military, and the other is not military directly. Another relevant situation is regarding with biological things, and there are some natural disasters involving pathogens, like the disasters of Ebola in the last years, about 2010, something like that, 8, 9. Inundations, that, for example, in Mozambique or in Bosnia or in Iran. Earthquakes like Amatrice in Italy, and contamination with bacteria, virus in hospitals or in other places like listeria, if I don't remember but now. The problems with pesticides in agriculture, that in some cases has done some local diseases. The World Health Organization publishes a list of emerging topics or the emerging diseases at any moment. So they have a monitor for that. And the initial list of disease priorities needing urgent attention for research and development normally is for medical situation, but okay. Are these hemorrhagic fevers, Ebola, Lassa, the MERS and SARS coronavirus diseases are in the list since several years ago. Now we see what this is happening now. And other diseases designated by Sirius, you can see here some influences. And above for at the same time that we have natural diseases, there are also the possibility of some bioterrorism to be considered. we have prepared 1 or 2 years ago these events, these chronological events in biological warfare agents. In fact, the biological warfare can be traced even to the Middle Age. But in the recent times, earlier, in the first quarter of the past century, in the 20th century, there has been a new protocol in Genova for poisonous cases, because after the First World War, there was a lot of problems in the trenches with chemical, but also biological systems. And there are a number of situations. And after some moment, it appears some use of bioterrorism. So we see here in the evolution the bioterrorism events, and the first one was in '84, that was a contamination in, I think it was near Chicago or Oregon place, but there were many others in the years. The very well known are the anthrax or the ricin toxin, or the last attacks in the 2013 here. So we see that there are natural problems, but also there is a possibility of terrorism, so intentional use. Also can be the use in war, although we see that there are some treatments, international treatments for that. Now we can comment the counter, or how to counter the threats. We proposed the use of robotics for set up countermeasures. And we propose the use of robotics based on the detailed evaluation of the current technologies, rapidity and accuracy, their possible improvement, and or the integration of mobile platforms, and on the development of new tools. At each step of the disaster or the event can be natural or man-made. The existing countermeasures will be identified and assessed. Identified where there are human, so we need to work with intelligence services, public and private security forces, and intervention teams, or technical. Communications and data intelligence, analysis measures, chemical, biological, radiological, explosive risk detection, and so on. And these situations need to be analyzed, and we need to determine if the current technologies can be identified in front of the disaster scenarios, see if the existing technologies can be used alone, can be combined with each other, at what cost, what is the balance effectiveness cost, and also are all the security objectives fulfilled by the existing measures. This interesting, very relevant diagram shows more or less the steps done for the preparation of prevention, protection, and intervention. So, first of all, we have some possibilities to prevent here, for detect alerting, and for delaying the event before it happens. Then, after the event, which is here, after the event, we need to protect the people that is going to be there to respond for the intervention, and so on, and to restoration of the system. We see the threats here for what we need to measure, and also we need to measure after the system. Different sensors here, or different intelligence, or different questionnaires, and here the same. We have the threats, the major event, and the consequences. So, for researching to counter the measures of these threats, it's possible to research in different steps, and in different steps it is possible that some kind of robots or associated technology of electronics, sensors, and so on, could be used to enhance, to better prepare these steps. These steps can be, of course, divided in more steps under. In one contribution that has been provided by the International Institute of CBRNE of Belgium, that organized a workshop with IMECO, RISE workshop. Then Mr. Alan Grimmer, that is the coordinator of a project with this name and belongs to Interpol, has prepared the meeting. This workshop was organized by Professor Baduan at International Institute that is done in very near Brussels, Les Bonvilliers, a small place south of Brussels. And this Mr. Alan Grimmer has prepared some slides that is kindly let us to give us some information regarding prediction and prevention, how it is done now. We have that Interpol is having a global presence all around the world, and so from this they have a number of possible ways of information. Based on that, there has been some plots, successful acquisitions and actual attacks, that in the years from 1990 to 2013, you can see here in the maps, you can see here that some events regarding CBRN, there are countries that has suffered many items, and others are less countries, but okay. there was a campaign in Europe since 2013, and you can see here the incidents in different countries. So you say here Spain, 11 incidents, France 27, and so on. So this is part of the system. You can see the let me say the elements used on this thread. There has been an analysis regarding how this is done, and you see here the complexity of all this situation. It's a very complex situation involving a lot of resources and a lot of people to understand that. For us, from this kind of robotics, we see that there can be attacks on land, on sea, and on air. UAVs or small places or other systems are used or has been used in some times. There are some situations where some cases that drones have been used for controlling the areas in some places. And also there has been many kind of drones that has been weaponized to perform some kinds of attacks. You can see some of them. The system, for example, this is a grenade projectile. Okay, now we can see how the role of robotics could be to help on this problem of threatening of this kind of explosive or chemical, biological, improvised devices. So now we will comment with an example of a recent project, how robotics assistance could be used to predict, prevent, detect, measure, protect, and manage explosive risks, or in this case, it will be explosive risks because Tiramisu project was only explosive risks, but could be this approach could be extended to another places that we are doing in different projects now. Tiramisu is the acronym of Toolbox Implementation for Removal of Anti-Personnel Mines, Submunitions, and Unexploded Ordnance. It was funded by previous research program from the European Commission with this number, the contract. It joined 24 partners for 11 countries in Europe, plus it's not here, but we have also some partners in Japan. And the countries in Europe were this. So you see that we cover many European countries. The Professor Ivan Baduan was the coordinator of Tiramisu project. Tiramisu is a toolbox. Frankly speaking, the idea of a toolbox is an interesting idea regarding these approaches to counter the CBRN RN threatens, because the situation is very complex. There are many actors, many situations, many possibilities, as we can see. So we see that the scenario is very complicated, very much complicated, difficult to control. So the idea is to analyze the system, top down, down top, any other way, and then to work in different places, and then to join the results. So the idea is, frankly speaking, is very interesting. And in the case of Tiramisu, all the project, most of the project, was regarding activities leading to land release. Why that? Why that? Because with the problem of anti-personnel landmines and cluster munition, the problem is that they have been placed in locations where you need, after the war, to recover the fields for agriculture and for other things. Apart from the contamination that explosives put on the soil, on the terrain, apart from that, there is the problem first of the risk. So you cannot go to cultivate if there are some anti-personnel mines there. And this is distributed in many countries. But also the problem is that you cannot enter there and destroy everything, because in this case there are explosions and you contaminate many things, and the fields are not good after for being cultivated. So you need to do some actions for land release. So in this case, in Tiramisu, there was some toolboxes or some tools that dedicated to land impact survey, for non-technical survey, for technical survey, for closing detection, for protection and disposal, for training, for mine risk education, for mission management. And then everything was working together in the Tiramisu toolbox. It's very important in the case of anti-personnel landmines to do the mine risk education, but in general, it is also very important the training of the people, the training of the first responders, the training of the operators for that. So this is more or less the panorama of, for example, just a few examples. For the non-technical survey, that then we have different possibilities. The objective is to confirm hazardous areas. So non-technical survey means that we explore satellite, airborne, mobile robotics on the surface, but normally in this case is non-technical surveys from up. And the idea is to confirm the areas. And then when you confirm the areas with indicators, for example, looking with some different wave lengths, infrared or some special wavelengths to detect something. For example, because we know that there are some explosives that affect the plants, and so there is a different color that you can see with different spectroscopical, hyperspectral information, and then you detect the area, and then you can reduce the area for searching So you cannot go directly to a very big area where you don't know nothing, but you have a lot of information from that. In Tiramisu, there has been a very important work on this area. And when you have done this area reduction, there is the possibility of using some kind of robots for detection and localization with high precision, with very high precision. And you can see in some demonstrations of Tiramisu project that with different kind of robots, can be legged robots, can be with wheels, with tracks, with manipulators, without manipulators, in this case manipulator, here also. You can use detectors, classical detectors with metal or ground penetrating radar, that in Tiramisu a very good work has been done for arrays of GPR and so on. We can use chemical or biological sensor. We use honey for that, but can be also in artificial nose that was developed, as far as I remember, by St Andrews University in Scotland. Also, intelligent plotters that has been developed by University of Catania or by us, with many resources. So there are possibilities of combining sensors and different kind of robots. Very important work has been done with computer games. So our technology that is being very much used in control theory and so on, of computer games for optimization and so on, has been done for the preparation of mind risk education, especially for children that need to go after to the school and so on, in these infested areas of landmines. And there has been a very relevant, has been very much recognized, the work done in Tiramisu regarding mind risk education. More technically, we have developed electronic training systems that has been prepared for the operators, for people that need to recognize mines when they encounter on the ground, and to be familiarized with them, so to decrease the risk of this situation. So it's a training, and training must be done, and in these modern times, electronic training, we consider that is an interesting idea, and that can help much on that. So these are some of the many electronic tutors that has been developed in Tiramisu project. I said at the starting of this presentation that CLAWAR Network and CLAWAR Association has been doing a pioneering work on robots to help, in particular for anti-personnel landmine detection and disposal and so on, but in general. And in particular, within CLAWAR, and apart from one of our colleagues from Japan, a big job has been done in the field of one of the fields of CLAWAR, of the topics of the specialities of CLAWAR, which is legged robots. We see yesterday some presentations regarding legged, some part of the presentation for legged robots for agriculture, for example. Okay, so CLAWAR has been working very much on legged robots. Could be walking, could be climbing also, and I think that in the field of humanitarian mining in particular, there has been a number of situations. Professor Baduan started many publications earlier than this. I found out this three. Professor Hirose also. Professor Hirose make the first plenary presentation, Professor Shigeo Hirose, in CLAWAR 1998 in Brussels, was the first CLAWAR conference, so many years ago. And also Professor Kenzo Nonami from Chiba University has developed a very nice project. Also, there is a pioneering work from University of Catania and also from University of Coimbra that has developed the control of the mining robots. As an example, from the works in CLAWAR network, there are some new projects arose from them, like, for example, the Silo 6, six-legged robot with manipulator, all the systems, GPS and so on, and sensors for detection of anti-personnel landmines. So some kind of legged robot. This is a detail of a first prototype using different kind of sensors for handling the N effector, going mapping the terrain, even for cutting the grass, because this is the one very important thing, to cut the grass before making the scanning and so on. Then in the case of the Tiramisu project, there was a system that has been developed from a previous system for a six-legged also system that with different sensors has been used for detection of anti-personnel landmines. Here is a possibility of another structure of this. In the last times, we are fusing a lot of information using time of flight cameras, different cameras of small ones, color cameras. Also, we can see here the infrared part and the color, the distance, and then the recognition of the terrain here. I think that we need to conclude. I make some very small recommendations or very small conclusion on that. On that, the first situation is that the situation of threats from weapons that are not conventional, like chemical, biological, explosive improvised devices, and so on, are a complex problem. It's a problem that exists. It's a problem where many people has been working, that there are an important interest in European Union for working on that area, because there are a lot of interest in many institutions and so on that. There is a full program on security in the European Commission, and for the point of view of robotics and associated technologies, there are some possibilities to contribute to that. We can contribute by the development of new sensors. New sensors means using previous sensors and then making combination, making data fusion and so on, and making new ones. For example, some area that is very interesting is the use of robots for forensics in some after some catastrophe, some incident has happened, and the use of sensors and of manipulators, manual manipulators and so on, could be of great interest. It is very important to develop reliable electronics, miniaturized systems on chip that are very relevant for that. Then it is possible to use existing technologies of autonomous vehicles or ground vehicles, autonomous robots with legs, with wheels and so on, development of manipulators or special grippers and so on, and also development of new kinds of robots. So new kinds of robots that has been used in very let me say mirror area, which is search and rescue. It's very relevant. So many kind of robots for search and rescue, for earthquakes and so on, that has been done and existing in many institutes or universities. A major role will be played by autonomous systems, so getting more autonomy, and this is in the side of artificial intelligence, the use of deep learning systems for recognition with computer vision or with other sensors and so on. And also, and not least, but last here, is the idea of improving protection equipment for first responders. So, because we were confronted with improvised devices, the idea of protecting first responders is very relevant. So, many measures of this and the use of robots, of telerobots for intervention, can be very good mean for protect the first users, to protect the medicals, the paramedicals, the police and so on, going to the point that. And also the use of these sensorics and these robotics after the event, after the incident, for the forensics, for understanding what happened and how. So with this, I conclude my presentation. Thank you very much. I would like to make some acknowledgement to Mr. Yves Broek, Managing Director for our International CBR and Institute, and for the Brigadier General Ioannis Galatas that help us and prepare some of the presentation. Thank you very much.
Thank you very much, Manuel. That was very fascinating presentation. Very complex scenarios, complex situations to deal with, of course. So there's a lot of work yet to be done, I think, I envisage. Okay, so I invite colleagues for questions. If your colleagues have any questions, please raise your hand or shout.
Hi, Manuel, can you hear me okay? It's Clive Loughlin here.
Yeah, please go ahead.
Oh, fine. Hi, Manuel. Hi. Many thanks for a very comprehensive presentation. I haven't actually got a question, but I just thought it might be interesting to read out a little news item that I was reading actually just before signing on today. It was in a sailing magazine, and it says, the Ministry of Defence is offering to pay £5 million to any company prepared to remove the rusting masts of the sailing ship Richard Montgomery, which has been laying on the seabed in the Thames estuary since it sank in 1944. Its cargo of 1,400 tons of explosives remain on board. Only the masts of the hazard to navigation are visible above the waterline. And I just thought that that just seemed to be a classic where you should be sending robots in to, you know, to remove these masts in a way that doesn't risk any human life. I'm just wondering if you've got any immediate thoughts of that, or if you know of groups that could perhaps tackle the problem.
Yes. Yes, Clive. Thank you very much for the question. I think that I have one slide here. Yeah. This question we have treated very several times, because I think there was one slide. No, I remove it. Okay, this thing happens. It's a pity because yeah, I remove it. Okay, there are. Okay. The first thing we understood, we see when the first time we visit the Royal Military Academy with Professor Ivan Baduan, also Professor Muscato, Gurbinder, and so on, we noticed that he told us that there are still, every day, they are finding some remaining of explosive ordnance in some beaches in the north of Belgium. So there is a lot of explosives, especially from the Second War. From the Second War in ships is really impressive. Yeah, and I think that there are some international efforts for that. But the contamination there for this is very important, because although theoretically they cannot contaminate, now they are starting to probably, I don't know exactly, to contaminate from now. So there is a big concern now. That I don't know if it's okay.
Well, yeah, that's I think there are a lot of these going on, and it just seems to me that it's a very definable, and I think, although challenging, still a possible task that can be tackled by, I'd have thought, the current generation of robotics that we, you know, that with the equipment we've already got, with ROVs and, you know, and teleoperation and various manipulators and undersea cutting devices, that this could be a good application. Presumably with 1,400 tons of explosives, you want to make sure that you're quite a distance away from it in case it goes off. But in this case, actually, it's not that what they're trying not actually to touch the explosives at all, but just to remove the masts. So anyway, that's a bit of a sort of a good application, I think. And,
yes,
and
yes,
like you say, I'm sure that there are many, many more around the world of a similar nature.
Yes, and I think that the situations for the frontier for robotics, we are going to have that in the topics we are working in CLAWAR', climbing, underwater, robots. There are a lot of possibilities. Nowadays, we are more focused on some applications like precision agriculture, for example.
Mm-hmm.
But the technology can be used in different areas. Now, precision agriculture is very relevant because of, as was explained yesterday in one presentation, there is an increase of population, a need of more food. So it is a need of let me say, industrialize the fields in some way, not only with tractors, but with more complex tractors. So there are a lot of possibilities with that. Thank you.
Fine, thank you. Thank you.
Okay. Thank you very much. One more question if someone has, because we've already run out of time, actually. Any more question? One more.